Hello once again, my name is Graphics. Today we want to solve another exercise in logarithm where we are told to solve for x in this expression. Now we have log 3 to the base of x plus log x to the base of 3 is equals to what? 5 over 2. Now the first thing you first of all look at is you look at the base. If they are the same, you continue working, but if they're not the same, you try as much as you can to make them the same. So the approach I will take here is to make these two base the same, right? So there's a law, recall, when you have log a to b and you want to make b to replace a to replace b, this you will do to be 1 over what? Log b to a. You can see that to give us what? 1 over log b to a. So if you do that, now if I input, so when we have the log of x to 3, it is going to give us 1 all over what? Log 3 to what? To x. I will input them here. So in putting it here, I'll say therefore the log of 3 to x plus, now I'm going to write this instead of this. So I'll have 1 all over the log of 3 to x equals to what? 5 over 2. You can see that? So in doing that, the next thing we're going to do here is to represent log 3x to be equals to p. So what you do is you say let p be equals to what? Log 3 to base x. So anywhere I see log 3 to base x, I'm going to be having this. So we'll have this will now be p, right, plus 1 over p, because anywhere I see log 3 to base x will give me p, to equals to what? 5 over 2, right? So from here, if I look for the LCM of this here, the LCM here is p. Let's assume that p is over 1. So 1 in p is p. P times p will give us what? P squared. Plus p in p is 1. 1 times 1 is what? 1. Equals to what? 5 over 2. Now we're moving. From here, if I cross multiply, this 2 is coming up. So we're having 2 into bracket p squared plus 1 equals to what? 5p. Because this p is coming up, time to multiply the 5, having 5p. So from here, if you expand, 2 times p square give you 2p square plus 2 times 1 will give you 2 equals to what? 5p. Now from here, you collect like terms, or you bring this 5p to the other side. So we're having 2p square minus 5p plus 2 equals to what? 0. So the only thing difference is that this 5p is coming to this side, and then it's coming to this side become negative. And I arrange them into descending order of their power. This is p squared, this is p1, and this is p0, and so on and so forth. Now from here, that leads us to our quadratic equation. So what we are going to do, we need to solve quadratically. Now, just like I said earlier, from here, you multiply 2p squared times p to give us what? 4p squared, and we have my negative 5p here. Now you look for two values, you multiply, that will give you 4, and when you plus or minus will give you what? 5p. So we have minus 4p minus p. Minus 4p minus p, if you multiply them together, right, it will give you 4p squared. Then if you remove the negative sign, minus 4p minus p will give us what? Minus 5p. So anywhere I see minus 5p, I'll replace it with what? Minus 4p minus p. So this will give us 2p squared minus 4p minus p. Instead of writing this minus 5p here. So plus 2 is equals to what? 0. So from here, we'll move forward by saying that 2p squared minus 4p, I'll put it in one bracket, plus minus p plus 2 in another bracket equals to what? 0 is what I did. Now you ask yourself, when you factorize this, what is common in both sides? 2p is common. So if I should bring out my 2p, I'll be left with what? P here, right? Minus, I'll be left with here just 2. Because 2p times p will give us 2p squared. 2p times 2 gives us 4p. The good news here is p minus 2 here, whatever is here, will surely be here. P minus 2. Now you now ask yourself, what would I multiply with p that will give us minus p? That is minus 1. So my minus 1 will be here. Right? So this is minus 1. Because minus 1 times p gives us minus p. Minus 1 minus times minus 2 gives us plus 2. So equals to what? Equals to 0. Now we move forward. From here, what is common to both sides? P minus 2 is common to both sides. Right? Then we have what? 2p minus 1. You can see 2p minus 1 and p minus 2 all equals to 0. Now if I take them one by one, I have p minus 2 equals to 0 or 2p minus 1 equals to what? 0. So from here, if you take this p to the rest, this 2 to the other side, we have p equals to what? Positive 2 or 2p is equals to what? 1. Right? Now if I make p the subject here, my p is equals to what? 1 over 2 or my p is equals to 2. But there's something happening here. There's something happening here. But p is equals to what? Log what? X to base 3. Right? If you remember that. Look at this. We said p equals to what? Log x to base 3. So what would us do from what I did earlier? We said that p is equals to 2, right? Or p is equals to what? 1 over 2. Is that taken? But we said that p is what? Log 3 to base x. So anyway I see p, I'm going to put log 3 to base x equals to 2 or log 3 to base x equals to 1 over 2. Now there's a law in logarithm that says that if I have log a to b equals to what? C, it is the same thing by writing a equals to b to the power of c. Look at this guy here, right? So recall. So from here, I can now say that from here, this will now give me 3 is equals to x to the power of 2 or 3 is equals to x to the power of 1 over 2. You can see that? So if this x is coming to this side, you know this 2 is over 1. When it's closer to the equals to sign, to give me 3, 1 over 2 is equals to x, or x is equals to what? 3 to the power of what? 2. You see what I did here? When this is coming to this side, it changes its position. The 2 comes to where the 1 is, and the 1 comes to where the 2 is. So we'll be having what? 2 over 1, which is something I'm saying 2. So we can say our x is equals to what? 9. Or our x is equals to what? 1 over 2. So any of these two question scenario is your answer. Right? Now if you want to check if you are correct, let's assume x is 9. Let's come here and see when x is 9. If x is 9, we want to check in for if we are correct. When x is 9, so we have log 3 to 9 plus log 9 to 3 equals to 5 over 2. We must have 5 over 2. So if you take 9 to a number in base 3, we'll have log 3 raised power 2, because 3 raised power 2 is 9, plus log 3 raised power 2, then we have 3. So we must have what? 5 over 2. So from here, this will come behind. There's a law that says when this come behind, you put 1 over of what you have here. So we're having 1 over 2 log 3 to 3 plus this will come behind 2 log 3 to 3. We must have 5 over 2. So from here, we know log 3 to 3, when they are the same values, become 1. So we have 1 all over 2 into bracket 1 plus 2 bracket what? 1, right? We must have what? 5 over 2. So from here, we now have 1 over 2 times 1 will give 1 over 2 plus 2. We must have what? 5 over 2. So if you look for the LCM of this is 2. 2 into is 1. 1 times 1 is 1 plus 1 into is 2. 2 times 1 into 2 times 2 is what? 4. So we're having what? 5 over 2. But you say 1 plus 4 is 5 all over 2. See that our value is correct, right? Similarly, if you try that for x equals to, you can do that on your own and you confirm that. You can try that for what? X equals to what? 3 raised power 1 over 2. You still get the same value. So this is to conclude that what? Our x is what? 9, or our x is what? 3 to the power of what? 1 over 2. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.